Okay, convert the following molecular formulas into line bond structures consistent with valence rules. So again, we're looking at sort of taking a trial and error approach, just noting that the formula doesn't tell us where the atoms are, but we can sort of get a start just by connecting the carbon atoms and really all the non-hydrogen atoms together. We could do it like this, or we could even say, let's put them into a cyclic structure like this. This would be propane or cyclopropane. And so 3 carbons for this one, and then 8 hydrogens. So let's just put the hydrogens around these atoms until we run out of hydrogen. So 1, 2, 3, 4, 5, 6, 7, 8. So notice I'm staying within the valence rules for carbon, which means that it can't have any more than 4 bonds around it. Let's try this case here. What if we tried it with cyclopropane? 1, 2, 3, 4. So notice each of these carbons is bonded to 2 other carbons. So I only have 2 places where I can put additional atoms. In this case, all we have are hydrogen atoms. So that was 2, 4, and 6. Now, there's no other positions where we could add hydrogen atoms here without exceeding the valency of carbon. And so this molecular formula would be C3H6, not C3H8. So this can't be it. And this propane molecule, it's called N-propane, or just propane, is the only possibility for this molecular formula. Now here with, let me just erase this little guy here. Nope, that's not going to work. The next one is AB, is CH5N. So let's look at CH5N. So that was A, B, CH5N. All right, so again, let's start with the non-hydrogen atoms, put a bond there, and then just fill in hydrogens. So let's just start with carbon because it's pretty easy. We know that it only has 4 bonds, or no more than 4 bonds. So there are 3 of our hydrogens. And let's put in the other 2 on nitrogen here and see what we get. Okay, so we're good with carbon, valency of 4, and it has 4 bonds. Nitrogen has a valency of 5. Remember, nitrogen is 1 over to the right of carbon in the periodic table. And so far we only have 3 bonds, so we've only taken up 3 of the valence electrons. And the easiest thing for nitrogen is to make up the remaining valence electrons in terms of lone pairs. So in this case, there's 1 lone pair around nitrogen, and this is the molecule. It's called methylamine. Okay, so let's move these guys over. And actually, I'll just shrink that a little bit and move it over here, make room. So C2H6O, C2H6O, and there are 2 possibilities here. So let's, again, start with C2H6O, start with the carbon atoms and the oxygen atom, and then we'll fill in the hydrogens later. And this is one way to do it. We could also put the oxygen between the 2 carbon atoms, and this could be the other way of arranging these atoms with this molecular formula. And now we just put in the hydrogen atoms. So starting with carbon, there would be 3 hydrogens on this carbon, and then now this carbon in the middle is bonded to 2 other things, so now it only has room for 2 hydrogens. So that's 1, 2, 3, 4, 5. We have one more hydrogen, and this makes 6. And oxygen, this is just like water, and you should probably already have a sense that there will be 2 lone pairs here, just from practice looking at water and knowing that oxygen with 2 bonds, 2 other bonds, has 2 lone pairs. In this case, let's try this. We'll put the 3 hydrogens around this one, and then we'll put the 3 hydrogens around here, and notice that now we have 3 hydrogens here, 3 here, so that makes up our 6 total hydrogens in this molecule. And then this oxygen, again with 2 things bonded to it, will have 2 lone pairs. And here we have our essentially two structures that fit this molecular formula. This is called, this one you may know, is called ethanol. And this one is called dimethyl ether. And these 2 molecules have the same molecular formula, but they have very different structures, very different properties. Ethanol, we all know the properties, or some of the properties of ethanol. Dimethyl ether is an anesthetic. It's a gas at room temperature. And so it has very different properties from ethanol. These are called isomers. So these are called isomers. That is, molecules different molecules with the same molecular formula. Okay, now let's look at number D, letter D, and I will try to lasso these guys so I can shrink them or move them, get them out of the way. And over here. Okay. Now let's look at D, C3H7Br. So D is, actually, where did my, D is, C3H7Br. So we'll start with the carbon atoms, 1, 2, 3, or we could have the carbon atoms again in a cyclic structure. So let's see if this works. Starting here, we have 3 carbons and 7 hydrogens. So let's just put the hydrogens in first. 1, 2, 3, 4, 5, 6, 7. And notice that there's one spot here on this carbon where we could put another bond to another atom, and here we have a bromine. So this must be where the bromine is in this molecule. So this has a molecular formula, C3H7Br. This one, if we start putting in hydrogens, 1, 2, 3, 4, 5, 6, well, we're done. We can't put anything else around here, so we've only got 6 hydrogens around this molecule. We need a 7th, and then we need to add Br. So this can't be the structure. The structure cannot have a cyclic carbon skeleton in it. And so we'll just leave that out as a possibility. But how else can we arrange these atoms and maintain this molecular formula? Well, we have the Br, the bromine, on the end carbon here. What if we put the bromine on a different carbon? So we have our linear sort of arrangement of carbon atoms. And let's put the bromine, instead of on the end, let's put it in the middle, on the middle carbon. And now we can fill in the rest with hydrogens. 1, 2, 3, 4, 5, 6, 7. This is also C3H7Br. Same molecular formula, but different arrangement of atoms. And so, in fact, these are very different compounds. This is called 1-bromopropane. Sorry, put that in pink here. This one here is called 1-bromopropane. And this one, as you might guess, is called 2-bromopropane. And we'll get to how these molecules are named in a later chapter. So that's D, and then I'll leave E and F for you to try on your own.